Hi everybody, I'm Eduardo Guerra. I'm going to present this paper. It's Journal First, my metric suite for code annotation assessment. It was published last year on Journal of Systems and Software. If you are not familiar with code annotations in Java, it is a language feature that allows you to add custom metadata to the programming elements. An important thing is that when you add code annotations, you don't actually add behavior. You're just only adding additional information that will allow other tools like frameworks or compile time tools to do some kind of processing and based on the information that is in class. So this feature was added in Java 5, and today it's widely used by many famous frameworks. So like HIBERNATE for object relational mapping, Spring that do a lot of things, and it's even hard to define, but originally it was born like injection for dependency injection container, but today use it for web services and other things. We have JUnit that's almost standard for unit testing in Java, and even other testing frameworks follow the same idea of using annotations to add this additional information. Just to add to what I just said, we pick up the 30 most popular Java projects in GitHub just for fun. And we found an average of 76% of the classes have at least one annotation. And the project that was least annotated was 26% of the classes annotated, and the most annotated 97%. So based on this, we can see that code annotations are important to be studied as part of the language. But we don't have many metrics and many ways to access the code annotations. So the goal of this work was to propose a suite of metrics for capturing information about code annotations, and also to be able to interpret these results to find some thresholds that we can use as basis to interpret these numbers. So, and we use percentile rank analysis. I will talk a little bit more about that. So our research questions were about, first one, what measurements we can do in a code annotation. The two about the thresholds for having reference. What is the common profile for an annotated code? And if we can find outliers, and how are these outliers? And I will give you a spoiler, they are scary. Okay, so this is our metric suite. We propose this suite of 7 metrics. I will explain really fast. So we have some class metrics. Annotations in class, how many annotations there are in the whole class. We have unique annotations in class. When we say unique annotations, are annotations that have a different type and different properties. We have annotations schema. What is an annotation schema? It's like, for example, if you have the JPA API, they define several annotations. So this this set of annotations from a single framework, it's one annotation schema. So the number of annotation schema in the class, we have some element metrics like lines of code in annotation declaration, how many lines of code you use to for an annotation, and annotations in element declaration for a single element, how many annotations do you have there? We also have the annotation nesting level, because you can have a property that the type is an annotation, and attributes in annotation, how many attributes that annotation have. So based on this, we created a tool called Annotations Sniffer that we implemented these metrics to study. It is a Java program that is it's a command line tool, but we also created an Eclipse plugin that uses this to extract these metrics. So we have 25 open source projects. They were selected considering the domain. For example, it's an application, it's a framework, and considering also the percentage of classes annotated. Try to pick up different profiles. And we see that because annotations kind of a late language feature, it's kind of optional. So usually we have like a lot of zeros and stuff in this. For example, we have many annotations without attributes. So we have many zeros, and then we start to have some annotations with that class. So because of this, we decide not to use the Lanza approach, to use the average value, but we use what is proposed by Meirelles, which by the way is one of the co-authors of this work, that say that some metrics follow this power law distribution. So this is the results of the, let me see, the thresholds. Just to see, here we have what we propose considering the very frequent, and less frequent, and here we have what was proposed by Lanza. And we can see, for example, that we have as a medium value several zeros or very low values. Just to see the different annotations in class, we have, for example, 11 is very frequent, and here it's 0. So we can see that our proposed approach for thresholds were more suitable for the kind of metric that we are proposing. So we also have some outliers. I like this picture. It's like the guy who kicked the ball. If he has a goal, above the goal he will miss too. So, so there are some outliers. If you see here, it's very big. Just for an example, we have in HIBERNATE a class with 729 annotations. It's a lot. And we also have an annotation with 58 lines of code. One annotation with 58 lines of code. Yes, they are little monsters. Okay, this thing can happen. And to finish, we propose a novel suite of metrics applying to real-world projects. We use the presentative rank analysis for identifying the thresholds. In general, the annotations have low values, and we found big outliers that call our attention that annotations may be an issue for code maintenance. We don't prove it, but these big outliers show that the thing can get really ugly. So that's it. I explained a little bit about the annotations, presented you the metric suite, the how we calculate the thresholds and talk a little bit about the outliers. So, thank you.